What are the two things we don't know in number 8? It tells you in the first 6 words.
Two exam scores.
Yeah, 2 exam scores. So what are you going to call one of the exam scores?
X.
X. And what are you going to call the other exam score?
Y.
Holy shit! All right, so now we're cooking with gas, right?
Right.
You're trying to bring in specifics way too soon. The first thing we do is just give a letter to things. So the first exam you can call X, or you can call it F if you want to, and the second exam you can call Y.
Okay.
Now tell me this, riddle me this. Does anyone remember what the range is?
It's like the highest score minus your lowest score.
I like it.
Range.
I like it. So we'll kind of assume, maybe we should just say it doesn't really matter. So let's pretend like the first one was the highest one. So how would you write an equation that tells that shows this? So for example, if she made a 76 on one and then a 62 on another, what would her range be?
62, 60. No, holy crap! I'm sorry, it's first thing in the morning. Is it?
Are you thinking about the mean? I'm talking about the range. How far apart are these two?
14.
14. What'd you do? You took one exam score minus the other exam score, and that equals the range.
Oh.
Now, what are the exam scores that we're working with?
Working with 90. Oh, no.
No.
X and Y.
There we go. 90 is not an exam score. It's the mean of the exam scores. Yeah. Now, don't worry. We're not talking about this at the moment. Don't even look at that, right? That's going to be a whole separate. So I'm actually answering part B, but I'm just doing it up here because I can see all this information. So are our exam scores 76 and 62? No. What are our exam scores?
X and Y.
X and Y. So how do I, and it should be, the range should be 12, right? That's what it says. And how do I get that range? What would I do with my exam scores to get the range? What do I do with them?
Oh, like an equation?
Yeah.
X minus Y equals 12. Sorry.
What is happening? Okay. All right, let me stop. Let me stop for a minute. Is everybody with us here?
Yeah, I thought there was like a fire drill going on.
Sorry, my bad.
Yeah, that would be a weird one. Everybody leave your house. Zoom fire drill. That's kind of funny. I like that. All right. I remember having tornado drills when I lived in Georgia and Florida. Anyway, that's one equation right there. I really want you guys to please make this connection. If I knew one score was 80 and the other was 71, how would I find the range? I would do one minus the other one to get the range. All right, well, what if I know that they're X and Y? I would do one minus the other one to get the range, whatever the range is. In this case, it was 12. I just want you, please, dear God, because where did I get 80 and 71? I made them up. Where did I get 76 and 62? I made them up, right? Or maybe one student got these 2 scores and another student got these 2 scores, but this student, this person got these 2 scores, some unknown number. But what would you always do, no matter what the numbers were? What would you always do to get the range? You would subtract them. That's all that equation says. That's it. Whatever the shit this is, minus whatever the shit this is the range. Make up 2 numbers. Isn't that exactly what you would do? Do you guys see what I'm saying? That's all an equation does, is it captures what you would do if you knew these things. Maybe. I know I'm getting a little excited, but
No, I'm tracking.
all right, because word problems and these kind of things are not as evil as people want to make them. It's just that you guys are so used to taking numbers and doing something to them directly, immediately. In algebra with word problems, we take unknowns and do stuff with them. That's all. It's this, what stuff? The same stuff you would do if you knew what the numbers were, right? I guess that means that one's done. What? Look at this other. How would I find the mean? Let me erase some of this stuff here. How would I find the mean? Let me make up two numbers. Let's use the 76 and 62. Let's say that one student got a 76 and a 62. How would I find the mean? What would I do?
Add and divide by 2.
Yeah, add them and divide by 2, and that would be 69. So everybody with me? Right? I would add the test scores, divide by 2, and if you do that, you'll get 69. Now, what scores did this person make? This person down here, what scores did she make? And this is where people kind of lose it. We don't know, do we? But we do. What scores did we say she made?
X, Y.
X and Y. Do you guys understand that? When I think when I asked that question, what scores did she make? You're like, how would I know? We don't know. We do. We called the first one X and the second one Y. So we know exactly what she made, X and Y. Maybe the more you understand what I just said, and I'm not playing around. I'm not being funny. I'm not whatever. She made an X and she made a Y, which means we don't know it, but we do call them those things. So then we can do shit with them. What would I do with her 2 scores to find the mean? What would I do with them? What do you always do with 2 numbers to find the mean? What do
Add
we
them
do?
together and divide by
Add them
2.
up, divided by 2 equals the mean. And what did it say the mean was?
90.
90. And I'll give you a little hint. Oh, look more like a 90. Yeah, Jeff, that looks, I don't know what that is. That is a poor little mutant number. Okay, well, that's not too bad. All right, I'll give you one little hint on the second one. You can multiply the 2 on both sides so you don't have a fraction in your equation, correct? And then I would highly recommend you do substitution method. Solve for a letter and plug it in the other equation. Is that helping? I mean, that has to help because I just did half the problem with you guys. Okay, I'm going to assume that helps. So maybe this is a good time for a review on what you would do next. Let me make up for a different student. Let's say a different student had a range of 18 and an average of you could do it, Jeff. Say something. 89. Is that all right? Right? This is just some other student. This is not her. This is some other student. You with me? All right. Here's how I would solve this. So I'll leave 1 alone. This one I'm going to multiply by 2. So I kill that stupid fraction. I don't want a fraction in my equation. So now I got X plus Y equals 100. And you can do it, Jeff. 88. Is that right? I think so. No. 178, some of this? Yeah, that's better, Jeff. Good try, buddy. Okay, let me silence that. Silence email, bam. Okay. Are you guys out there? Are you guys with me?
Yes.
Tristan is.
Yes, sir.
We got both of my Trish people with me. All right, all right. I'm just trying to help you because these are the equations you have to use. I'm showing you what I would do with some other student, right? So to do substitution, pick one of the equations and solve it for a letter. So somebody pick an equation and then pick a letter to solve for somebody. You want equation 1 or equation 2 to work with?
Equation 2.
Equation 2. Cool.
Yeah, why not?
And then what letter do you want to solve for?
Y.
Y, 11. So I'm going to subtract x, right, to get y by itself. So now I get y. So now I know this is a fact. I know that y is 178 minus x. I know that's true.
Could we not just do elimination on this?
Well, I didn't teach elimination. I
Oh,
love
my bad.
elimination.
My bad.
I love elimination, but that would be a whole other thing.
My apologies.
And I don't think this book talks about elimination, which kind of sucks because it's my favorite thing in the world. I might show it on the side here in a minute. But now I can take this. What can I do with this? I'll tell you what to do with that, Jeff. Hey.
Substitute it in.
Yeah. Now, Tristan, you've kind of inadvertently made this a little harder than it had to be. That's all right.
I thought we would do elimination. That's why I picked the Y.
I'm with you. So watch this. So if I rewrite this, this is x minus, right? Isn't that what it says? X minus y, but what's y? Y is this. That's all elimination. I'm sorry. That's all substitution. Now you got me thinking about it.
So
that's all substitution does.
It would make it negative 178 plus x now, right?
Yes. Plus x, that'll be 2x. Add 178, add 178. I get 2x equals 196. Is that what? I don't even know. Divide by 2 and you get 98. Sure, Jeff. So that's one test is 98. Then I can use this to figure out the other test has got to be 80. All right, that's enough. I've given you. Real quick on the side here, just in case any of you remember this or are curious, here's what elimination would do. You can add the equations together. So this is 2x, the y's cancel. 18 plus 178 is 196. And do you see how, didn't we eventually get to that same equation over here? Yes, Jeff. Okay. What's weird is, I don't know. Has anyone ever seen that before? I know Tristan has. Anybody else ever seen this elimination method? You know, then I can solve this and plug it back in.
No.
No? Okay. And I don't want to spend a lot of time on this, but real quick, why should it be legal to add two equations together? Aren't you supposed to add the same thing to both sides? Did I think about, oh, I see. Yeah. Okay. Don't worry. All right. What was I just saying? Somebody just private messaged me. Hold on. What was it? Oh yeah. If I add, and this is the last thing I'll say, if you don't quite understand this, you're fine because you don't have to know how to do this. If I add 18 to this side, aren't I supposed to add 18 to the other side? Yes, right? Isn't that how equations work?
Yes.
Okay, but isn't 18 equal to this? Right? Doesn't this say that 18 is this? Yes?
Yes.
So if I add 18 to this side, I can add x minus y to this side, and I have added the same thing to both sides. That's why I'm actually allowed to add two equations together. And why would I ever do that if one of the letters cancels? Huh?
That's neat. Doesn't it help you get rid of one of the variables?
Of course. Now, here's where it's gross. You ready? What if I had this equation and this equation? If you add them together, does anything cancel? if you add them together, does anything cancel up
No,
here?
Yes.
no.
No.
What would cancel? What do you mean? Nothing cancels. There would still be an X, there would be 18Y, there would be 14. Nothing cancels.
Oh, okay. I got you.
So then you would have to like multiply the first one by 4 and the second one by -5. That would make both of these 20, except one is negative, and then you can, yeah, so elimination gets gross if the coefficients are gross. All right, I'll stop. All right, that was a lot. That was so hopefully you focused on what was important to help you with number 8, part B and C. Okay, we went a little bit off script there, but that's all good. All right, let me clear all this away. Here it goes. You ready? Go. Okay. Anything else from homework? Anything? Anything? Nothing?
Question 9, please.
9 where?
310.
Oh, 310. Oh, wait. Oh, 310, where we are right now. Okay. This one?
Yes.
Okay. They tell you they need 80 liters. All right, now, so let me help you with how to set things up here a little bit. So we have a 33% solution, right? We have a 5% solution. Now, real quick, just the physical idea behind a 33% solution means 33% is disinfectant and the rest of it is water. You guys with me? Have you guys ever used like cleaning stuff for floors and you had to mix it with so many gallons of water before you did it because otherwise it will eat the varnish off of things or whatever?
Yes.
Okay. So we have a 33% solution. So it's kind of like heavy on the disinfectant. And then we have a 5% solution, which means 5% of it is disinfectant and the rest is something like water. Okay. You have to understand what I just said to do the problem? No. Does it make the problem make a little more sense? Hopefully. So if I mix these two together, isn't the end result going to be somewhere in the middle? So if I put 5% into the 33%, isn't that going to dilute it? Isn't it going to make it less potent? Does that make sense physically? Do you guys understand what I'm saying?
Yes.
If I have a 5% solution and I pour it into a 33% solution, it's going to become 32%, 31%, 30%, 19%. So it makes sense that eventually I would get it down to 12%. Okay. Again, do you have to understand what I'm saying right now to do the problem? Actually, no, you don't. But it makes it make more sense as to why this works and what's going on. All right.
Excuse me, Professor.
Sure.
Sorry, I was lying. I don't get it actually. So, so 33% solution, you put in a 5% solution, it goes down 1%.
Well, if you put enough in, it'll go down 1%. Sure. So, all right, let's do this. Watch this.
Sorry.
You're fine. You're fine. Let me do a concrete example real quick. This is beautiful. This is what I want. This is what I want. Do not apologize. I don't understand why you're apologizing. You're fine. This is the whole thing. This is not immediately obvious necessarily, so it's fine. All right. Let's do a concrete example. So I'm not doing number 9 right now. I'm doing a concrete different example. So let's say I have, it doesn't really matter, Jeff, does it? Let's say 9 liters of this. And I have, what, Jeff? 3 liters of this. Is everybody with me? All right, so how many liters am I going to have at the end when I mix these together?
12.
12 liters. All right. Now watch this. How much, if you were paying attention, You understand how to do this. How do I figure out how much disinfectant is in this, is in these 9 liters? How much disinfectant? Is it 100% disinfectant? Is all of it? Is it,
30%?
sorry? So
33%.
33%. So what is 33% of 9? Yeah, it's not too bad, Jeff.
3.
3.
Well, let's be more precise, everybody.
Okay.
2.97. Right. I know, I don't know. Did you guys think 33% is 1/3?
Yes.
And it isn't really. It would be 33.33333. That's why it's a little.
Yeah.
All right. Everybody with me? That's all. So just put 0.33 times 9. Are you guys with me?
Mhm.
So if I have 9 liters and 2.97 liters of it is disinfectant, that would be a 33% solution, correct? That's what that means. 33% of it is pure disinfectant. Stay with me. Come on, you can do it. I used to do this with chocolate milk, where you have milk and you add chocolate, right? That's a little bit better than water and disinfectant, but oh well, too bad. What about this guy? Same question. How much disinfectant? How do you figure that out?
5%.
Of
Or 3.
3. I like it. So how much disinfectant is in this one? So it'd be 0.05.
0.0, 0.02. If we rounded, it would be 0.0166.
It should be what's happening?
So
0.05 times 3.
Oh, I divided.
Oh, okay.
0.15.
Yeah.
Apologies.
Because we know 5 times 3 is 15.
Yeah.
And then just a couple decibels. You guys, so that's 0.15 liters. Does that make, if I put 0.15 liters of the 3 liters is disinfectant, that means 5% of it is disinfectant. That's what a 5% solution means. Okay, I like it. Have you guys ever, real quick, little side note, have you ever went to the hospital and you had to get a saline drip? Has anybody ever been in that experience? Anybody ever heard of saline?
Yes.
Yes, okay. And I don't want you to dredge up bad memories, I'm sorry, but I've also gone through that. And you hear the nurse or somebody say, we need a 3% saline solution, which means 97% of it is water and 3% of it is salt. All right, so that you don't want to put pure water into somebody's blood. That's not good. It needs to have some salt in there. All right. So that's kind of like what this is. This is a 5% solution, meaning 5% of it is disinfectant. So is everybody with me? Physically, I would have this many liters of disinfectant in this guy, this many liters of disinfectant in this guy. So how many liters of disinfectant will I have in the result, in the end? Jeff, how do you spell disinfectant? I forgot already. Disinfectant. Oh my God, this is why I freaking teach math. All right. Just tell me how many total liters of disinfectant at the end? Not a big deal. This one's got this much. This one's got this much. When I add them together, how much do I have?
$3.05.
3. No. What happened?
3.12.
3.12 sounds better. You add 2.97 and 0.15, right? Can you see this in your mind? So I have this 33% solution. So 33% of this is disinfectant. You see there? There's the disinfectant at the bottom of the little beaker dude, right? I got a little beaker of this stuff. And then I add it to a 5% solution. So there's a little bit of disinfectant for the 5% solution. Are you guys with me? So I have 2.97 liters in here and 0.15 liters of disinfectant in there. So how much I'm going to have at the end? 3.12. Now, can somebody tell me what percentage is the final mix? what percentage of disinfectant is in the final mix? How the shit do you figure that? Well, how much disinfectant is in the final mix? How many liters? How many liters of disinfectant is in the final mix?
3.12.
Good. Out of how many total liters?
12.
12. So 3.12 divided by 12, what do you get? Ooh, I like this. This comes out really nice. I wish I could take credit for this beautiful answer. 3.12 out of 12.
0.26.
So 26%,
Yeah.
yes?
Yes.
All right, now let's talk. So here's the math. 33% solution plus a little 5% solution made it go down to 26% solution, yes? Why does that make sense? Because I'm adding to this 33% solution, I'm adding all this water and a little bit of disinfectant. Yes? Yes. What's the quickest way to dilute something? Add pure water, right? Does everybody agree that if I had a 33% solution and I just added more water, wouldn't that number go down? Wouldn't it be less and less and less percent disinfectant if I just added pure water? Is anybody not with me? If I just added more and more water, wouldn't this percentage go down? Because now it's less disinfectant related to how much water there is. So this is a 5% solution. It's not going to go down as fast, but it's still going to go down because I'm adding 95% of this is water. So I'm mostly adding water to this. So of course it's going to get diluted. Does that make more sense? No, none of it makes any sense, Jeff. Jeff, you suck so bad.
Kind of.
Kind of. If I added the same amount of this with the same amount of that, the end result will come right in between these two.
Yeah, that makes sense.
So if I add a little bit less of one and a little more of the other one, the end result will be closer to this one, but still in the middle of these two.
Yeah.
That's it. That's all. That's it. That's all. Is 12% closer to 9? I'm sorry, 12% closer to 5 or 33? Is 12% closer to 5?
5.
5. So which one of these am I going to use more of? I should end up with more of the 5. See here, I used less of the 5, didn't I, in this example? And we just took the 33 down a little bit to 26. If I want to get it all the way down to 12%, I'm going to have to use more of this one. I love you guys. I love you guys. What was it we did down here? We did a percentage of the total plus a percentage of the total equals a percentage of the total. All right, so let me back up. So what I've done is I tried to show a concrete example to explain the physical thing about what's happening behind this word problem. And again, I mean, maybe I should have just started with pure water. That might have been better. If I just add pure water, it's obvious that this is going to go down because now less of it is disinfectant, right? More of it's water. So if I add something that's a very small percentage disinfectant, it's almost like adding pure water. So it's still going to go down. I'm still diluting it effectively. Okay. Now I'm going to erase a big chunk of this. You ready? Here it goes. Let me erase my beautiful pictures. None of your pictures are beautiful. I know. That was the joke. Okay. Go away, go away, go away, go away, go away, go away. Okay. I was just asking, I was just wondering, why did I write the word concrete? Oh yeah, because it was a concrete example. All right, go away, little sponge. Now, do I know, let's talk about this problem specifically. Do I know, what do I know for sure? What do I know for sure? Do I know anything for sure? What do they just tell me for certain in this problem? Number 9. What do they tell me? Just tell me.
A hospital need 80 liters.
Right. So I know that the final is going to have 80 liters total, and it's going to be a 12% solution, correct? All right. And then it says, how many liters of each? So do I know how many liters of this guy or this guy? Do I know anything? No, I have no idea how many liters of those, right? Okay, so what do you want to call this one?
X and Y.
That's crazy. All right. So can I write, look at this very simple equation I can write right now. What must X plus Y be?
80 liters.
Yeah, is everybody with me? Is everybody with us? I got X of this plus Y of this has to make the 80 liters total, correct? I really don't want to do this whole thing. I'm going to do one step on the second equation. Now, somebody else. Thank you, Wafa, but let me see. Somebody else. Can you tell me, can you remember? Can somebody tell me how much disinfectant is in this?
12%.
Yeah. Or 12
No,
liters.
come on, guys. I love you guys. 12% is the final. I'm not talking about the final mix. This guy right here. This guy right here. How much disinfectant is in this thing?
33
33% of what?
of X.
There we go.
Okay.
So the amount of disinfectant in this guy is 0.33x. Now, if you can figure out the amount of disinfectant in this guy and the amount of disinfectant in this guy, you've got your second equation. Is it going to be pretty? You guys think it's going to be pretty? No, it's going to have all these decimals running around. Oh, too bad. But once you got it set up, you can do substitution. You got a calculator. All right. I took you most of the way. See if you guys, so I got to do is what we did right here. You just got to do it twice more and you have an equation here. Then you can solve the first one for X or Y, plug it in the second guy, and that's all I'm going to say. I've said more than I wanted to. That's it. And again, if you thought every problem in this class was going to be easy, I don't know where you got that thought from. So is this an easy problem? No, it's not. Is it impossible? No, it's definitely not impossible. All right, I'll stop. So I'm going to clear this away. I'm so excited. This is good. This is what I desperately want. Some of these problems are weird as shit. If nobody asks me questions, I get concerned. All right, I'm going to clear all this away. You guys ready? Everybody's got what they want? Okay. Any other questions from homework? No, you guys are okay. All right. Let's see, where did we leave off? I think we got through 4.2, right? We talked about 4.1, that's inductive and deductive reasoning. And then we got into 4.2. We talked about Pythagorean theorem. We still have to do distance formula. So let's talk about, well, first off, yeah, I mean, Pythagorean theorem, you guys should be relatively good with that, right? I mean, let's just do a quick example real fast. If I have a right triangle, get out of there, Willow. And this is 7, and this is 24. Can you figure out what this side is? Another one bites the dust. And another one bites. Yeah, you can't do that, can you? I think. 21. 41. Yeah, okay. Bum, 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 ba-dum. Bum, 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 ba-dum, bum, bum. What are you going to call this side?
C.
C square.
You're going to call it
Oh, no.
C.
C,
You're gonna
yeah.
call it C, yeah.
Oh.
Because it's across from the right angle. And how are you going to set up the equation?
7 square plus 24 square equals C square.
Good. The most important thing is that the longest side needs to be over here by itself. Now, believe it or not, this is going to come out nice. This is going to come out to be a whole number. So you get 49 plus, what is that, Jeff? Twice that is 600 minus 24 is 576. Is that right? Nobody's going to help me? It's too bad, math boy. You should know.
Oh, sorry. That was funny. Plus.
What's up?
Are we trying to find what C is, right?
Yep.
Okay.
Let me see. I'm going to help myself. So it is 576, Jeff. Oh, okay.
No, I got it.
And
We'll do it. 625 is 25 times 25, right?
yeah. So then you can just do the square root of that sucker, and you do 20.
Sorry,
So
I was
this is
just
25.
distracted for a moment.
Let me show you some kind of neat. What's 24 plus 25?
49,
And what's the square root of 49?
7.
Oh. Does anyone remember another triangle? 3, 4, what? Does anyone know? 3, 4, what triangle?
Is
5.
it 5?
5. What's 4 plus 5?
9.
What's square root of 9?
3.
Ah, there's also a 5, 12, 13. What's 12 plus 13?
25.
What's square root of 25?
5.
Sorry. But these are just the very, very special cases. If you just made up two numbers out of nowhere, this is going to be gross. Whatever the hell that is, it's going to be gross. Right? It's just the way it is. What is that? Square root of 170, I think. If I did that right, maybe, yeah. Are you guys semi with me? So there are some triangles where the numbers just happen to work well in the equation with each other. But most of the triangles that you just sort of make randomly, the last side is going to be gross. It's going to be some kind of square root of something gross because you got to take a square root to do this, right? Okay, all right. Let me clear all this away. Clear? Okay. Let's talk about distance formula. Why do they have a quote from John Bon Jovi? I don't know. All right. We're halfway there. All right. We're more than halfway actually in this class. Where do I want to go? Give me some. Oh, here we go. Perfect. All right. All right. Let's do a concrete example before we do this weirdness. Let me see if I have some blank space. I do. Okay, let's use this blank space. So what we're about to try to figure out is if I give you 2 points, can you find the distance between the 2 points? So, for example, if I had this point and I have this point, and I want to know what this distance is between them. Why is this not immediately easy? For example, if I had this instead, this point and this point, that's easy. How far apart are those 2 points? No, is that not easy? Am I over assuming?
Two.
All right, Let me give you some scale. I'm just using, if I don't put a scale, it's just by 1. So is this distance 2?
Yes.
But the minute that they are diagonal from each other, that goes to shit, right? I can't just tell how far apart these are because they're diagonal. They're at some angle from each other. Oh my God. Can anyone see a right triangle here?
Yes.
Yes.
I like it. So there's a right triangle here, right? Jeff? Jeff, I swear to God, Jeff. Jeff. Are you feeling okay? All right, let's try this again. Here we go, buddy. Oh yeah, you can do this. Just you always got this at your disposal. That's right. You forget. All right, there it is. Look at that beautiful triangle now. I'm not proud. I can use that. All right, stay with me, Stan. I don't know why I make these so small, these pictures I do, but I'm sorry. What point is this, by the way?
That is,
1, 2.
I'm gonna mess it up, but yeah, 1, 2.
All right, what point is this?
5,
0.
Careful. So it's going to be X first and then Y, X, Y, alphabetical order. How would I figure out, and what's special about this side compared to the right triangle that we just discovered? What's the name of this side? What angle is it across from?
C.
All right, it's what we normally call C, but what's its name? It sounds like a type of animal. Hippopotamus? It's hypotenuse, right?
Yeah.
Are you guys doing okay?
Yes.
Slow down a lot. I've just got a right triangle, right? And this is the hypotenuse, hypo, blah, 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 blah. And why am I gonna call it D here? Just because in this case, it represents distance between 2 points. So in mathematicians, we like to use a letter that relates to what it means physically. Okay. So I know normally we call it C, not a big deal. We can call it whatever the hell we want to. Now, how would I find out this length? What would I have to know about these two? I have to know those lengths, right? What is this length on the graph? What is this? Why is this easy? Because it's like this, isn't it?
Yeah, it's 2.
2, that's 2. And what's this length?
5,
Careful.
4.
4.
Yes, it doesn't start at 0, it starts at 1. So this is, everybody see that? Now, how did you get 2? You did, are you ready? How'd you get, oh shit. How'd you get 2? You did 2 minus 0, right? This is the Y2 and this is Y0. How'd you get 4? You did 5 minus 1. This is 5, this is 1. Just right, isn't that kind of, you know, like that's not how I got it, and basically it is. You just didn't do the math exactly like that. Now, can you figure out this side then? D squared equals
2 square plus 4 square.
let me do this weirdness. Ready? Let me make this. Ooh, this looks weird, Jeff. So I'm just doing the square root a little bit early, right? You guys all with me? This is exactly what we did earlier with the right triangle.
Mhm.
It's just in these problems, I have to figure out these side lengths. In the problems before, I was giving you the side lengths, just telling you the number. Here, you got to take a second and figure out what the hell they are. And that's not difficult. It's just how long is this? How long is that? Not a problem, right? And then you finally get 4 plus 16 square root of 20. Can somebody give me an estimate of what this is?
$4.5.
Sure. All right. I like it. It's somewhere between 4 and 5 because it's somewhere between 16 and 25. I like it. All right. So let's do this. If I didn't know what the points were exactly, that's the next page. I'm going to clear all this away. Are you guys ready? Here it goes. It's gone. Okay. So look here, look at this. Oh, this is so beautiful. This is so beautiful. So in this case, I want to know what this distance is, but I'm not sure. These 2 points could be any points. Can somebody please tell me how long this is?
3.
All right. I appreciate that very much. Let me tell you that the scale is unknown. Just using what I know. Can somebody tell me what this is right here? For the what is this? You could do it. You could-
Zero?
no. I love you guys so much. Come on. All right, no, stay with me, stay with me. If I told you that this point right there was 4, 5, can somebody tell me what this is?
4.
4. Everybody with me? Everybody with Wafa on me?
Yeah.
That is completely 4. Of course it is. What's this?
5.
5. Freaking 5, isn't it? All right, sorry. You guys understand?
Yeah.
So what is this?
X.
No. Oh, what happened? We were so there. Why did we say 5 here? Because what axis is this? What axis is
Ah,
this?
okay.
Is this
Y
the
axis.
x-axis or the y-axis?
That's the
Y.
Y-axis. So why we say 5? Because that's the y piece.
Okay.
So what's this? What point is there? So what is this?
Y0, maybe. I don't know.
Is it 0,5?
All right, I love you. So watch this, watch this. All right, stay with me. A little lightning round. What if I put a point here and it's 3, -2? What's this?
3.
3. All right, so you do that so wonderfully. Why did you say this was 3? What if I would have put a 4 here? What would this have been?
4.
Oh, shit. So whatever I put in the
Mhm.
first spot is the X piece. And what's the Y piece?
-2.
-2. What if I would have put a -3 there? What would have this have been?
-3.
Holy
Okay.
shit. Now, stay with me, 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 stay with me. What if I put AB? What's this?
A.
Yes. All right. So is anybody not understanding what's happening? This has got to be A, this has got to be B, and that's why the point would be right. So what's this?
The problem here, you don't
Look at the
mention
point that's
about the
there.
point. You mention about the line outside. That's why it confuses
Don't
me.
understand. What's this?
Is it 1 in 5?
If you mention about the point, maybe it's easier, but the scale, I don't know.
You guys are so funny. Why were you so cool with this? You were so cool with this. There's an A here because there's an A there. What is there? Isn't there an X1? Yes. So isn't this X1? Isn't this Y1? Same exact way we just did A and B. Isn't that point X1, Y1?
Oh
Yeah.
yeah.
You guys see that? Isn't that point X1, Y1? The same way that point is AB.
Yes.
So isn't the X piece X1 and the Y piece Y1? Yeah, I like it. Maybe. Is that a? Let me know if that doesn't make sense. I really hope I'm not coming off as overly frustrated, but y'all did this one perfectly, and then this one is the same thing. It's just not A and B. So what about this? What is this point, right? What is this piece right here?
X2.
Y squared.
Y2.
Y2.
I mean, Y2, sorry.
I like it. I like it. I'm with you. I'm with you. And what's this one, of course?
X2.
X2.
X2. Okay. Now, can somebody tell me what this is? How long is that? So guys, if I had, oh, I got a chat. Oh, give me strength. Okay. Unknown scale, everybody. Unknown scale. Does this go by 1, 2, 3? I don't know. So you cannot say this is 3. I have no freaking idea what the scale is. Now, stay with me. Stay with me. We just did an example earlier. If I have a point at 1, 1 and have another point at 4, 3, right? 1, 2, 3, 1, 2, 3, 4. What is this distance here? What is this distance here?
2,
Yeah, 3 minus 1.
1.
What is this distance here?
Yeah. Y
squared
Y
minus, I
square
mean,
minus
y2 minus
Y1.
y1.
Okay. Does that sound at all familiar? Does that sound like it's part of what? Y2 minus Y1 over? No?
X2 minus
x2
Y1.
minus x1.
Yeah. So guess what this is? I mean, don't guess. Actually, see what it is. How long is this?
X1 minus X2.
X2
X2
minus.
minus X1.
Yeah, okay.
X2.
So this is kind of neat. If I did this divided by this, I would get the slope of this line. But is that what I want? No, I want to know how long this line is, correct? Right? So what I'm going to do is exactly what we did earlier. I'm going to do d squared equals, stay with me now, this side squared. I don't know why I'm doing this. Let me change this right now. I might as well do it in alphabetical order so it matches with the general equation. What happened? Why can't I erase this? Okay, there we go. Got it. All right. So this side squared plus this side squared. Are you guys? This is grosser than a nice compact right triangle with numbers, but it's exactly what we did, isn't it? The hypotenuse squared equals this side squared plus this side squared. That's all that says. And then I could take a square root. Jesus, Jeff, come on. There we go. Here, let me show this to you. And don't worry, don't try to write that down. The book has got it written down on the next page. I'm pretty sure. Let's find out. That is the distance formula. It comes from Pythagorean theorem because the distance between 2 points on an XY plane makes a little triangle. And we know a lot of things about right triangles. So I'm going to clear this all away, and then I'm going to show you the actual equation written in a better writing. Give it to me. Give it to me, book. There it is. Look at that. That's the thing. That's what it is. So, for example, and then we'll call it a day. Yeah. So let's say I have the points 1, 1, and 4, 3. Why not? Can we figure out the distance between those?
Yes, we can.
Yes. So what do I put in here?
1 and 4.
Yeah, and it doesn't really matter. I don't know if you guys understand. Why can't I put 1 minus 4 or 4 minus 1? Because I'm going to square it.
Mm-hmm.
So it doesn't matter. So I'm just going to do 4 minus 1, make it nice and easy, right? And then what goes in here?
3 minus 1.
3 minus 1, the y's. I love it. So then I get the square root of 3 squared is 9 plus 2 squared is 4, square root of 13. I'm done.
Mhm.
So how far apart are the points 1, 1 and 4, 3? They are square root of 13 steps apart. Okay, All right. I love you. guys.
Professor,
Yes.
So we would keep it as a square root though? We wouldn't.
Depends on
Making
the
it-
situation. If it's a purely math question, you can stop there. If somebody's like, how far is it to the post office? If I go straight to the, as the crow flies, then I would go ahead and stick this in the calculator and get an approximation, right?
Okay.
Because again, if I say, how far is it to the post office? And somebody says, oh, square root of 13 miles. I'm like, I am not going to talk to you anymore. I love math, but that's weird. Go away from me. Right?
Yeah.
Yeah. It's like, are you related to Spock? No. Okay. So that's another. So we have Pythagorean theorem, and Pythagorean theorem directly leads to this equation. So I can find the distance between any 2 points. You know, and some of you guys are like, I didn't need to know that. All right, too bad. You know it anyway. All right, so that's enough, guys. That is plenty for today. I'm gonna stop sharing. Let me know if you need to hang out. Oh yeah, I'm sorry. The quiz. Let me talk about the quiz real quick. What I want to do is we have tomorrow off. But I have office hours tomorrow still. I'm still gonna have my office hours tomorrow. I just have the meeting in the morning like I very often do. So what I want to do, give me a minute. Let me see if I can keep myself straight here. I want to open so the quiz is supposed to happen today, but what I'm going to do, I'm going to open it up tomorrow morning, and then I'm going to give you until Saturday morning to get it done. Everybody with me?
That sounds good.
Sounds good.
So don't look for it today yet. I'm going to open it up tomorrow morning, and then then you have some time, because if you want to get some more help, you want to come to my office hours tomorrow, you still can, and you still have a decent amount of time to get it done. Okay.
all right, thank you, Professor.
Thanks.
You're welcome.
Have a
Okay.
great weekend.
You too.
Thank you.
Everybody's good? All right.
Yeah, real quick. What's the
Yeah.
quiz on? Sorry, I've just been balancing phlebotomy homework and math homework. So I'm like, yeah.
So the last quiz went up to 3.4. So this quiz is going to go from 3.5 to 3.10. So it's just
Gotcha.
in the last part of chapter 3.
All right. Perfect. All right. Have a good day.
You too. All right. I'm headed out.